For this equation, we want to find all solutions on the interval from 0 to 2 pi, and we want exact answers. It says here to give an exact answer means you do not use your calculator, so you may have to use inverse trig functions in your answers. So let's keep in mind we're not going to use the calculator. The first thing I see here is I have both a cosine and a sine, and it would be nice to get them in terms of the same trig function, but the other thing I notice is one of the arguments or angles is 2x and the other is x, and we want them in terms of the same argument as well. So I'm going to use a double angle formula. I know that cosine 2x equals cosine squared x minus sine squared x, but there's two other versions. There's also 2 cosine squared x minus 1 by just simply replacing the sine squared x with a 1 minus cosine squared x. Similarly, we could replace the cosine squared x with a 1 minus sine squared x and get 1 minus 2 sine squared x. So those are the three versions of the double angle formula. Which one would I want? Well, because I have this sine x here, I'm going to use the one that just gets things in terms of a sine x, and then I can get everything on one side equals 0 and see if I can factor it. So I have the 3 in front. I need to make some parentheses because I'm going to plug in 1 minus 2 sine squared x, which is what cosine 2x equals, but the 3 will need to be distributed to both. And then I'm going to move the 4 sine x over and the 1 over. So they become minus 4 sine x and minus 1, and the right hand side becomes 0. So this is going to be 3 minus 6 sine squared x minus 4 sine x minus 1 equals 0. So let's now put this in descending order and combine like terms. So I'm going to have negative 6 sine squared x, I didn't put parentheses around that, minus 4 sine x, and then I have a 3 minus 1, so plus 2 equals 0. Now, I don't like a negative on my quadratic term, my squared term, and also I see that there's a 2 in everything, so I'm going to divide everything by negative 2. I can do that as long as I do it to all terms on both sides of the equal sign, and what that leaves me with is 3 sine squared x. This negative and negative will make this one a positive, and that'll be 2 sine x, and here a positive divided by negative will be minus 1 equals 0. Now I'm going to see if I can factor that, so I'll make my two sets of parentheses equal 0, and if it is hard for you to factor it with trig functions, you can replace the sine x with the u and factor 3u squared plus 2u minus 1 equals 0, and after you get it factored and solved, you can resubstitute and put the sine x back in. But I think we're going to factor it with leaving it in terms of just sine x. So first term, I'm going to need two things that will multiply together to give me 3 sine squared x, so 3 sine x and sine x. And I need the last term to be negative, so I need 1 plus and 1 minus. I'm going to put the plus here and the minus here because the factors are 1 and 1. I did it that way because outers now are plus 3 sine x, inners are minus 1 sine x, which gives me the right middle term. So there it is factored. Now I need to set each factor equal to 0 and solve it. And I'm going to do that in one step because I'm kind of out of room. So the first one, if I set this equal to 0 and solve it, I move the 1 over and divide by the 3. So one of my equations, I need to figure out the values what angles have a sine of 1/3 between 0 and 2 pi. That's not a unit circle value, but I'm supposed to give exact answers, so I'm going to need to write this in terms of an arc sine. And so what I'm going to do is I am going to take the arc sine of both sides, and these will undo each other, and x will be arc sine of 1/3. Now that's one answer. but we have to think about arcsine only gives us one answer, but there are two places on the unit circle that would have the same sine value. The first of those, because it was positive, is something in quadrant 1, but the sine also has that same value in quadrant 2. And if I'm looking here, if this is the angle that has a sine of 1/3, to get the second angle that does, I would go around to pi and subtract off that value of that first angle. So another answer is going to be pi minus that angle, which was arcsine of 1/3. So you just have to leave them in terms of arcsine. Now let's go to our second equation, and if I put that equal to 0 and I solve it, I would get sine x equal -1 when I move that 1 over. So where between 0 and 2 pi is the sine -1, and that would be at 3 pi halves. So I've got three solutions here, and because they were not unit circle values, I just list them in terms of the inverse sine or arcsine function.